Okay, can see the screen?
Okay.
Someone on the mic?
Can, teacher.
Can, huh? Okay, right. Okay, so okay, this is chapter 2, so you are using MS2. Okay, so index for today. Okay, just write this. Forming quadratic equations from given roots. Okay, so this is index for today. Today is 25th. So do in your MS2. Okay, before that, look at this. Okay, you may copy this in your notes. Okay, factorization identity. Okay, so you can how to say, expand one by one. Okay, then after simplify you get this. Okay, so this is for x plus y whole thing squared. Okay, you get this. X minus y whole thing squared, then you get this. And then this one, x squared minus y squared is equal to x plus y and x minus y. Okay, this one I think you learned before. Okay, last time maybe you learned a squared minus b squared is equal a plus b, a minus b. Okay, so this one you can work from the right hand side, you expand. Okay, you will get this. Okay, so these three you must be, when you see this very fast, you know what is that answer. You don't have to do the expansion one by one, then really take time. Then you cannot finish your questions. Okay. Okay, let us start with this. Okay, a quadratic equation, this is in general form. Okay, can be written in this way. Okay, this one is we want to make the coefficient for the x squared is 1. Okay, therefore we divide every terms by a. Okay, so the first term when we have a x squared divided by a. Okay, so it cut, so you left x squared. Okay, so this one b over a, c over a. Okay, then 0 over a is 0, so you write back as 0. Okay, so we assume, okay, alpha and beta. Okay, always when we when we learn the roots for a quadratic equations, okay, the two roots we'll label it as alpha and beta. Okay, make sure you know how to write alpha. Don't write as a. Okay, alpha is this way when you write this way. Okay, don't write as a. This is your a. Alpha is this way. Okay, then beta is down first and then this is beta. Okay, alpha and beta actually is stand for a and b. I think in what Roman or Greek or something like that. Okay, so if alpha and beta are the roots, okay, you can write in this way. Okay, what's the meaning? Okay, you remember when we solve for quadratic equations, last step we have x equals to what, and then x equals to what. Okay, this is the answer. If now you say that x equal to alpha is the answer and x equals to beta is the answer. Okay, what is the step before? What is the line before these two? Okay, always is this x minus alpha equals to 0, and then x minus beta equal to 0. And then what is the line before this? Okay, always will be this x minus alpha bracket x minus beta, okay, equals to 0. Okay, then actually this is come from the factorization. Okay, you start from the quadratic equation, then you factorize. Okay, then you come to this, then only you come to this. So now they work the other way around. Okay, they work from the back. Okay, so they give you, okay, alpha and beta is the root. Okay, so I can write this. Okay, x minus alpha in bracket, x minus beta in brackets is equal to 0, is from here. Okay, then you do the expansion. Okay, you will see this. Okay, then they ask you to compare this and this. Okay, therefore you can make the conclusion. Compare means you compare one by one. Okay, the coefficient for x squared, this is 1, this is 1. Okay, then only you can able to compare the following one. Okay, this is why just now I divide every term by a, because I want to make the coefficient for the x squared is 1, because here is I have 1. Okay, then when you compare the coefficient for the x, okay, so this is the one, negative alpha plus beta, okay, in bracket, okay, is equal to BOA. Now, okay, this is the one. Okay, then when you compare the constant term, okay, so this is alpha times beta is equal to COA. Alpha times beta is equal to COA. Okay, in another way, okay, this is a summary of it. Okay, in another way, okay, you can write in this way. Sum of root. Why you say sum of root? Because alpha and beta are the root. Plus means sum. Okay, so sum of root alpha plus beta is equal to negative BOA. It's come from here. They move the negative to this side. Okay, so alpha plus beta is equal to negative BOA. Okay, next one, product of root. Okay, why you say product of roots? Product means multiply, times, multiply. Okay, therefore the roots is alpha and beta. Alpha times beta, product of roots, means you multiply that two roots. Okay, so you get C over A. Okay, this A, B, and the C is in the general form. In the general form, the coefficient for the x squared, coefficient for x, and the constant terms. Okay, so this is how you relate the roots of the quadratic equation with the A, B, and the C. Okay, this is very important, and this one is not given in the formula. Okay, so this one you have to write in your notes. Okay, and then always because we don't write sum of root so we write the short form. We write SOR. Okay, SOR, we call SOR. Okay, then product of roots also we write the short form POR, POR. Okay, then we say SOR, POR, SOR, POR. Okay. Okay, then finally you can make these conclusions. Okay, therefore the quadratic equation with root alpha and the beta can be written at this way. Okay, this one also is very useful. Okay, so it's x squared minus SOR, okay, x plus POR, then equals to 0. Okay, this is come from where? This one is come from where? Okay, we go up a bit. Okay, x squared. Okay, so you see x squared minus alpha plus beta, sum of root, okay, x plus alpha times beta, product of roots, equals 0. Okay, this one is when the question gives you the alpha and the beta, asks you to write in the quadratic equations, then you can use this. Okay, after I show you examples. Okay, and before we continue, okay, I would like to do this activity. Okay, before I give the example. Okay, given alpha is this, beta is this. Okay, show that alpha plus beta is equal to negative BOA. Okay, so I'm going to show this. Okay, I open in okay, you have your hard copy of textbook. Okay, so okay, they give this alpha is negative B minus B squared minus 4AC over 2A. Okay, and then beta is negative plus B squared minus 4AC over 2A. Actually, it's either one. You can set this one as a beta also. You can set this as beta, and then you can set this as alpha. Actually, it doesn't matter. Okay, because alpha plus beta, okay, is same as a beta plus alpha. And then after that, you have a alpha times beta. Actually, it's same as a beta times alpha. Okay, the same thing. So this one doesn't matter which one you set as a beta and which one you set as a alpha. Okay, so now part A. Okay, show that alpha plus beta is equal to negative B over A. So I start from the left hand side, which is the alpha plus beta. Okay, I'm going to do until the end. Okay, I hope that I see the negative B over A. Then I say shown. Okay, so let's start. Okay, so alpha is this. Okay, negative B, okay, negative square root B squared minus 4AC over 2A. So I copy the whole thing. Okay, plus, okay, beta is this thing. Okay, same thing, I copy the whole thing. If your basic of the maths not strong, all this, you feel like, oh, very scary. Okay, so a fraction plus a fractions, then you check the denominator. Okay, the denominator the same, so you can combine, become one fraction. Okay, then the numerator you just copy. Okay, this is plus. Be careful, if this is minus, then the sign here got to change. Because this is plus, so just remain the sign. Okay, next. Okay, you can simplify this. You can see minus this and plus this. So this whole term you can get rid of it. Okay, so negative b minus b, negative 2b, 2a. The 2 can cut. Okay, therefore you get negative b over a. Okay, this is the one that you want to show. Then you write shown. Okay, so this is for the part A. Okay, next, part B. Okay, express the product of alpha times beta, in terms of A and C. Okay, actually you know the answer already. Okay, alpha times beta should be this one. Okay, alpha times beta should be C over A. Okay. Anything? Why blinking? So far okay Okay, no questions Okay, so for this part, express the product of alpha times beta. Alpha times beta, okay, is C over A. I know the answer already. So afterwards, I should get C over A. If I didn't get C over A means something wrong already lah. Okay. So alpha times beta. Okay. Same thing. Okay. The alpha is negative b squared minus 4ac over 2a. Okay, this is alpha times beta. This is beta plus b squared minus 4ac. Okay, over 2a. Okay, now, okay, because this is times a fraction times a fractions so numerator times the numerator, denominator times with the denominator. Okay, therefore you have this. Okay, this is numerator. Okay, denominator is 2a times 2a, so I get 4a squared. Okay, now for numerator, okay, this is two brackets, so you got to expand it term by terms. If not, you see this okay, you can assume this is x minus y, x plus y. Okay, you can see. Okay, I use another color. You can see this is x, then minus this as the y, then again this is the x plus, and same thing, this is the y. Okay, so x minus y, x plus y, x minus y, x plus y. Okay, we go back to the textbook. Okay, just now I mentioned to you, right? All this is very important. You have to be very, very sensitive. Okay, just now is what? X minus y, x plus y. X minus y, x plus y. So your answer should be x squared minus y squared. Okay, I come back here. Your answer should be x squared minus y squared. Okay, if you know all this, you take less time for your expansion. You know, you got to expand one by one. Okay, so x squared, your x is negative b, so negative b the whole thing squared. Okay, minus y squared, this is the y. Okay, square root b squared minus 4ac. Okay, whole thing squared. X squared minus y squared. Okay, this is for your expansion. 4a squared. Okay, then continue. Okay, this one will get b squared. Okay, minus, remember, if this is minus, you got to be careful. You got to put a bracket to protect it. Okay, after that you bring in the minus or the negative, only you can throw away the bracket. Okay, so the square root and the square, it will disappear. So b squared minus 4ac. Okay, over 4a squared. Okay, I think I continue here. Okay, so here you open out the bracket, bring in the negative. So negative b squared, negative, 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 negative become positive 4ac. Okay, over 4a squared. I still didn't see my answer c over a yet. Okay, b squared minus b squared, this one gone. Okay, so I have a 4ac over 4a squared. The 4 and the 4 can cut, the a and the a can cut, so c over a. I got an answer already, c over a. Okay, so this is how, by using the alpha as the formula. Okay, and also the beta, one is a plus and one is a minus, and then to get uh, what we want to show just now lah, okay, which is sum of root is negative b over a, and then product of root is c over a. Okay, so we come back to the example 3. Okay, you can look at your textbook, the example 3. So I change to another page. Okay, so this is example 3. Okay, form a quadratic equation with root 3 and negative 5. Okay, 3 and negative 5. Okay, there are two ways of doing. So we start with root is, you have a 3 and negative 5. Okay, one way of doing is follow the textbook. Okay, first of all, we find SOR. Okay, sum of root. Okay, so sum means plus. Okay, add the two roots. Okay, so 3 minus 5 negative 2. Okay, then next continue POR. Sorry, POR. Okay, product of roots means times. Oh, so negative 50. Okay, so we go back to the textbook. Okay, I'm going to use this. Okay, I'm going to use this. Okay, to form the quadratic equation. So x squared equals to SOR, and then x plus POR equal to 0. Okay, so I'm going to use this x squared minus SOR, x plus POR, that equals to 0. Okay, so x squared SOR, okay, take from here, negative 2. POR, take from here, negative 15, okay, 0. So x squared, negative, negative become positive. Negative, positive become negative. Okay, so this is the answer. Okay, this is method number 1. Okay, I have another method. Okay, method 2. Okay, this one is very simple. Okay, let's like just now. Okay, I go back to the textbook. Okay, I'm going to do like this. Okay, like just now, this one. I'm going to do like this. Okay, work from the bottom going up. Okay, start with this. X is equal to what and x equal to what? X, okay, the two roots. So x is equal to 3. One of the root. Okay, the other one, x is equal to -5. Okay, so you know that. Okay, actually, this is what you're going to get. Okay, so but be careful with the sign. Okay, because this one you can think in this way. Okay, because this is +3, go here, -3. This is a -5, go here, become +5. Okay, so x minus 3, x plus 5 equal to 0. Then you do expansion. Okay, this and this, x squared, this and this, plus 5x, this and this, minus 3x, this and this, 15 equal to 0. Okay, group the like term, this and this, plus 2x minus 15 equal to 0. Okay, there are two methods. Okay. Okay, next we go to example number 4. Okay, this is example number 4. Okay, if alpha and beta are the roots, okay, of the quadratic equations. This question is very common. Okay, so I start with the quadratic equations. Okay, the 4 I should bring to the left hand side. Okay, become -4 equal to 0. Okay, I write in the general form. Okay, form a quadratic equation with the following roots. Okay, this one, okay, the roots is alpha and beta. Okay, this kind of questions okay, don't care what you're going to do. Okay, the first step is find SOR, find POR. Okay, so we start with SOR. Okay, SOR, sum. So alpha plus beta. Okay, alpha plus beta. Okay, go back to the textbook. Alpha plus beta is what? Alpha plus beta is negative b over a. Okay, negative b over a. So come back here. Okay, negative. What is the b here? Okay, if you want, you can list out. A is 2, b is 1, and c is -4. Okay, negative b over a. So -1 over 2. Okay, nothing you can simplify, nothing you can do. Just leave it, because afterward you're going to use this alpha plus beta is equal to -1 over 2. Because this question, I don't know what is alpha, I don't know what is beta, but I know that alpha plus beta is -1 over 2. Okay, so after you got to make use of this, but not alpha, but not beta. It's alpha plus beta. Okay, same as POR. Okay, POR, alpha times beta. Okay, or alpha beta lah. Okay, alpha times beta, what do you have? Alpha times beta is C over A. Okay, C over A. C is -4 over A. A is 2. Therefore, I get -2. Okay, I'm ready. Okay, if afterwards I see alpha plus beta, I'm going to replace it with -1 over 2. If after I see alpha times beta, I'm going to replace it with -2. But I can't, or I don't know actually what is alpha, what is beta. Okay, so this is for the first part, okay, of this type of questions. Okay, now we can answer the questions, the A. Okay, the question asks, form a quadratic equations. Okay, means at the end you got to show a quadratic equation with the following roots. Okay, now for the part A, the root is alpha plus 3, beta plus 3. Okay, alpha plus 3, beta plus 3. Okay, same thing. SOR. Okay, SOR is what? Sum of root means this plus this. Okay, so alpha plus 3 plus beta plus 3. Okay, so it will become what? I got to rearrange it because I want to know, because I have alpha plus beta. Okay, so I got to rearrange so that the alpha plus beta stay together. Okay, then 3 plus 3 is 6. Okay, therefore here, you see alpha plus beta, I can apply, I can substitute, I can replace it with the negative 1 over 2. Okay, so this is negative 1 over 2 plus 6. Okay, so the answer is 6, 12. 12 minus 1. Okay, so 11 over 2. Okay, so this is a SOR. Then same thing, POR. Okay, POR is times, okay, the two roots. So alpha plus 3 times beta plus 3. Okay, do the expansion. Alpha beta, 3 alpha, 3 beta, 9. Okay. Okay, same thing. I got to rearrange it so that I can see alpha beta and I can see alpha plus beta. So you see alpha beta is ready. So after I'm going to replace it with the negative 2. Okay, now I try to arrange this so that I can see alpha plus beta. Okay, very simple. You just factor out 3. So balance inside will be alpha plus beta. Now you can substitute. Okay, you can replace it. Alpha beta is negative, and alpha plus beta is a negative 1 over 2. Okay, plus 9. Okay, from where I get this is from the up here. Okay, alpha times beta is negative. Okay, alpha plus beta is negative 1 over 2. Okay, then calculate D. This one I should get okay, same thing, 11 over 2. Okay, therefore, how to write the quadratic equations? Okay, I go back to the textbook. I use this. Okay, I use this. Okay, because I have a SOR, POR, I use this. Okay, to write out the quadratic equations. Okay, so I'm going to use x squared minus SOR, and then x, okay, plus POR, okay, and then equals 0. Okay, so x squared minus SOR here 11 over 2, POR 11 over 2 equals 0. Okay, if you don't want us to see fractions, okay, very simple, just times 2 to every terms. Okay, times 2 to every terms. So you have a 2x squared. When this one times 2, the denominator will disappear. Okay, so 11. Okay, same as this times 2, so it becomes 11. Okay, so this is your final answer. Okay, in general form. Okay, and then no fraction. Okay, this is A. Okay, then you will see some of the question is not that easy to expand. Okay, we continue. Now for B. Okay, B, you have a roots as 2 alpha and then 2 beta. We rest for a while. Now it's 9:33. We come back at 9:35. Girls, only 30 girls here. Please help me to check who is not here. Okay, come back already. So any idea who is not here?
Janice.
Janice, someone can call her. Just now, 8 o'clock, what do you have?
We don't have any lesson.
Oh, you don't have any lesson. No wonder, so cannot wake up, is it? Who is talking just now? Shafia, is it?
Yeah.
Safia. Can someone help to call Janice? If you don't have Janice contact someone, please. Who can help? Who is Janice's good friend in this class? Okay, Kasri. Okay, she will call her. Okay, very good. Okay, then I continue my lesson. Okay, now this. Okay, so we continue. Okay, after the example A, so now I think I can go a little bit faster. Okay, so same thing, SOR, sum. Okay, alpha plus 2 beta. Okay, same thing, I need alpha plus beta together. So I put the equal here better. Okay, so I factor out 2. So alpha plus beta. Okay, alpha plus beta is a negative 1 over 2. So I replace it with negative 1 over 2. So cut, I get negative 1 for my SOR. Then POR. Okay, times 2 alpha times 2 beta. So 2 times 2 is 4. So become 4 alpha beta. Okay, so this alpha beta, same thing. I'm going to replace it with negative 2. Okay, so 4 times negative 2. So it's negative 8. Okay, now I'm ready with the SOR, POR, so I can just write out the quadratic equations. X squared minus SOR, okay, X, and then plus POR. Okay, always this one you got to be careful with the sign. Okay, always the student will make mistake with the sign. The rest is no problem. Okay, so remember it's X squared minus SOR, and then X, and then plus POR, and then equals to 0. Okay. Okay, so here negative become positive. Positive 1x, the one on the right, so plus x. Positive negative become negative. Okay, so this is the answer. I don't know, can I write the C here? Okay, C is the root R alpha squared and then beta squared. Okay, now we have SOR. SOR sum. Okay, so add Okay, now more and more complicated already. Okay, I can't see alpha plus beta. I can't see alpha times beta. I only have alpha squared plus beta squared. Okay, so I go back to the textbook. Okay, look at this. Maybe I can find something from here. Alpha squared, beta squared. Alpha squared, beta squared. Alpha squared, alpha squared. Okay, can you see this? I want you to pay attention on this. Okay, the B one. Okay, I'm going to write in the pen. Where do I write? Okay, I use another color. Okay, I write it here. Right here. Okay, that one is from the flashback. Okay, your textbook the B. Okay, I want to play some magic for you. Okay, you see, here I have alpha squared plus beta squared. So I'm going to make use of this. X squared plus y squared. So this term I don't need, right? So I'm going to throw to left hand side. Okay. Not this lah. Should be plus. Sorry, I take a wrong one. I should take the A one sorry. This now. So plus. So plus because I have SOR plus Okay, so this one should be plus sorry. Okay, so throw to this side become minus. Okay, therefore I can write in this way: alpha plus beta. Okay, the x as my alpha the y as my beta Okay, so it will become alpha plus beta squared. Okay, follow this minus 2. Okay, alpha times beta. Okay, now you see my SOR is here, POR is here. Okay, therefore this one I can continue. Okay, alpha plus beta squared 2 alpha beta. If this thing you don't know, then very difficult already. Cannot continue. Okay, so I'm going to replace alpha plus beta. Okay, SOR is a negative 1/2 squared, and then alpha beta is negative 2. Is it negative 2? Okay, so negative become positive 1. Okay, 2 times 2 is 4. This is plus 2 times 2 is 4. Therefore, I get 5/4. Oh, sorry, not 5/4. This is 4, not 1. Okay, so I get 17/4. 4 times 4, 16. Correct, 17/4. Okay, continue. Okay, this is SOR. Continue with POR. Okay, POR. Okay, POR. Alpha squared times alpha squared times beta squared. Okay, this one easy. Okay, so just alpha beta. Okay, then whole thing squared. This one as I know, you bring in the square so it become alpha squared beta squared back. Okay, so alpha times beta is negative 2. Again, the whole thing squared. Okay, so negative become positive. This is 4. Okay, then last step. I think I can write here Okay, so write out the quadratic equations. X squared minus SOR 17/4x plus POR 4 equals to 0. Okay, if you don't want 4 here, don't want the fractions, times 4 to every term. Okay, 17 times 4. Okay, the textbook something wrong. They didn't change it. 17 times 4 is what? 17 times 4. 68. Sorry, correct. My mistake. Because times 4 just cut. So here is 17. Okay, 16. I don't know what's wrong with me today. Okay. So correct. Okay, so this is for example 4. Okay, then today your homework will be self-practice 2.2. Okay, we come back to the textbook. So done. Okay, this one will be your today homework. Self-practice 2.2. Okay, then this one maybe I want to help you a little bit for question. We can try it. You see all these are quite complicated. Question 3 look okay. Question 4 okay, more complicated. Okay, so we discuss here a bit here now, so that after some when you do exercise, I think you can do it smoothly lah. Okay, but I'll do like that day, maybe call your name for the question that you can answer lah. Okay, then for the question that I think you need my help, then I will help you. Okay, this is self-practice 2.2. Okay, then this is question number 4. Okay, so beginning of the parts okay, they start with the alpha, beta are the roots for the 2x squared plus 5x minus 1. That one you do by yourself. Okay, I want to straight away go to the A. Okay, when they give the roots. Okay, you remember your SOR, POR, you got to adjust, you got to rearrange them so that you can see alpha plus beta or alpha beta. Okay, so 1 over alpha, 1 over beta. Okay, SOR. Okay, plus this one, I can't see alpha plus beta. I can't see alpha beta. So what I'm going to do? Okay, wait I want to get my name list. I think here. Oh, okay. This one I think I didn't show you yet, that day. A few girls didn't achieve the band 3 lah, So I read out your name, You double check is it correct or not. Okay. But your mark is quite near. You all mostly get, for those didn't achieve one, you all get like 14, 13 like that lah. Okay. So I hope next round you got no problem to achieve it lah. So Farha, okay, Janice, Kanakasri, Noizati, and one more girl here is Sivagami. Okay. Okay, so okay, Emmeline. Emmeline here?
Yes, teacher.
Why so soft? Can you talk louder a bit?
Hello.
Very soft. Okay, can you suggest to me? I'm not sure whether you can do it or not. Can you suggest to me? Make something to this so that after maybe I will see the alpha plus beta and alpha beta. This is a fraction plus fractions. Okay, I give you a clue. Combine these two fractions, but they have a different denominator. Okay, so what you're going to do?
Don't know, teacher.
Don't
know.
I repeat my questions. You see, fraction plus fraction. I'm going to combine these two fractions. They have a different denominator. So what I'm going to do?
Then times to change the denominator.
Yes. Okay. So the first term what I going to times?
Times beta.
Okay, very good. Times beta here. Okay, here also times beta. Okay, how about the second terms?
Times alpha.
Okay, times alpha and then times alpha. Okay, very good. Okay, thank you. So these are going to get beta and then alpha beta. These are going to get alpha and then beta alpha I write in alpha beta. Huh? Okay, so next, okay, I combine these two. Okay, since they have a common denominator, I just write once. Okay, then beta plus alpha. I can write alpha plus beta. Okay, now you see alpha plus beta is here. Alpha beta is here. Okay, now continue with the POR. Okay, so 1 alpha, 1 over alpha times 1 over beta. Okay, this one quite simple. Okay, so up numerator times numerator, 1 times 1 you get 1, denominator times denominator. Okay, alpha beta. Again, you see alpha beta is here. Okay, so this part A is solved. Okay, now we come to part B. Okay, I have to give Emmeline one mark here. So we continue with part B. We still have 10 more minutes. Okay, the roots is alpha plus 1 over beta. Wow, so complicated. Beta plus 1 over alpha. Okay, now SOR. SOR is what? Sum. Okay, plus. Okay, for this one, you don't go in think how to combine all this. Okay, first of all, this and this, alpha plus beta. Okay, done. After that, I have this. Rearrange. Okay, this one you have the answer already. Okay, this part 1 over alpha plus 1 over beta. Can you see here? 1 over alpha plus 1 over beta. Okay, the answer is here. Okay, so the part B questions actually is deleted from the part A. So after that, you get the SOR for the 1 over alpha plus 1 over beta. Okay, you just substitute into this. Okay, you just substitute into this. Okay, this one is from your part A. Okay, then how about POR? Okay, POR means times. Okay, two brackets. Okay, so term by term you expand. Alpha, beta. Okay, alpha times 1 over alpha. This one. Okay, beta times 1 over beta. Okay, last term here. 1 over last term. 1 over beta times 1 over alpha. Okay, so alpha beta done. Okay, this and this can cut. Okay, you get 1. This and this can cut, you get another 1. Okay, this part, okay, numerator 1 times 1, denominator alpha beta. Okay, so you can replace the alpha beta. This one also you can replace the alpha beta. Okay, this one 1 plus 1 then is 2. Then you can continue. Okay, this is for the part B. Okay, now part C. Alpha squared, beta squared. This one I don't want to explain because it's same as just now the example. Part C, okay, is beta squared. Okay, this one is same just now the example for part C. Okay, now we come to D. Okay, roots is alpha over beta, beta over alpha. Okay, so what we see what will happen. Okay, sum of root plus. Okay, alpha beta plus beta alpha. Okay, so same thing. I want to repeat my questions, but to the another girl, Itasha. I don't know whether you still can hear me. My network is not good. I don't know what's happening. Others can hear me or not? Someone with mic? Okay, on the mic. Okay, Emily. Now can. Okay. Okay. Itasha here? Itasha. Okay, I think she right. Okay. If you got no mic, very difficult to answer my question, lor. Okay. Never mind, I call another girl. Okay, next girl got mic or not? Faha. Faha got mic? Faha? You don't have You don't want to answer my question, Kritika.
Yes, teacher.
Oh, finally. Okay, come. Okay, just this question is almost the same like just now Emmeline answer that questions. Okay, you see these two fraction and fraction. I want to combine them, but they have a different denominator. So what I'm going to do?
The left hand side one times alpha, then the right hand side one times beta.
Okay, so we don't call it right hand side, left hand side because there is no equal sign here. The first term, okay, the first term you times what?
Alpha.
Okay, times alpha. So this one also times alpha. Okay, left hand side lah. Okay, the second term you times beta. Okay, times beta. Okay, thanks for your help. Okay, so now you have a common denominator which is beta. Okay, here is alpha squared and then beta squared. Okay, alpha beta settle. Okay, alpha squared plus beta squared. This one is from your part C. From your part C, you see alpha squared, beta squared Your SOR is alpha squared plus beta squared So this one you can straight away take from your part C. Okay, so this one settled. Okay, now we come to the POR. Okay, I have to remember to give a Kritika 1 mark here. Okay, now POR is a product of products of roots. Okay, so times. Okay, I think this is simple. Okay, cut. Okay, so after cut, what is the balance? Oh, my question is so simple. Okay, Itasha, I give you back. Okay, Itasha, you can type. What is the answer? Okay, after I cut, what is the balance? So simple the questions. You don't answer wrongly, please. Itasha, type. Okay, and then tell me what is the answer. 1, thank you very much. Okay. If you answer 0, then okay, I don't know how already. Okay, so the answer is 1. Okay, then you continue. Okay, so I think that's all for today. Wait for a while. Okay, now how just now who call Janice? Kana Kasri, is it? Kana Kasri. Okay, you have called her. Okay, I stop recording.